Hello students, welcome to KENE'S Educare, a group of KENE'S solution. Now in this session we are going to consider lesson number 15, Fun with Magnets from class 6 standard. Now, what is a magnet? बचपन से ही ये magnet देखा है. So magnet simply attracts the ion particles. Okay, it has the ability to attract ion particles. So what we are going to see in this chapter, we are going to consider the magnet and what are the fun that we can do with the magnets. Simply what are the applications of magnets वो हम देखेंगे. Let's start. So basically, can you tell pins in a pin holder do not fall even when it is held upside down? Why it is so? कभी आपने ये डिब्बा देखा है? Okay, जो भी पिन्स इसमें रहते हैं, there is opening from this end, but still this pins does not fall down. They do get attached with this surface. Why? While we are shutting the door of fridge, we find that it closes automatically from a certain distance and does not open unless pulled again. Why this is so? तो जब भी आप फ्रिज का डोर ओपन करते हो एंड क्लोज पॉइंट पे लाते हो तो वो ऑटोमेटिकली क्लोज हो जाता है. Why it is so? Because the magnet is used in these gadgets. A magnet is fitted in the cap of a pin holder and in the door of fridge. Iron objects stick to a magnet. तो iron object की ability क्या है? They stick with the magnet. Now what is a magnet? The material to which object made from iron, nickel, cobalt get attracted to the magnet. So not only iron, nickel, cobalt do get attracted to the magnet. Okay, and this property of material is called magnetism. Okay, just property से ये सारे material magnet को attract होते हैं, उस property को हम बोलते हैं magnetism. Okay, so iron has a magnetism, nickel has a magnetism, cobalt has a magnetism because they get attracted to the magnet. Now let's try this. Take a magnet from a laboratory and bring it near a various objects in your use. Which of them stick to the magnet? What material is each of them made up of? And observe these things carefully. Classify the object into two groups. Those which stick to the magnet and those which do not stick. तो हमें क्या करना है? We have to classify the object in daily to day life जो मैग्नेट के साथ स्टिक होते हैं लेकिन जो नहीं स्टिक होते. तो अगर मैं प्लास्टिक कंसिडर करूँ तो प्लास्टिक स्टिक नहीं होगा, लेकिन अगर मैं सेफ्टी पिन कंसिडर करूँ तो सेफ्टी पिन स्टिक होगा. दीज आर द ऑब्जेक्ट्स फ्रॉम डेली टू डे लाइफ. सो अभी हमें क्या करना है? टेक अ मिक्सचर ऑफ सैंड, piece of paper, sawdust and iron filling and pins in a saucer and pass a magnet around the mixture. What do you see? See, we have to take a mixture of sand, paper, sawdust, iron particle. तो इसमें से iron filling जो है and the pins in the saucer will get attracted to the magnet, लेकिन piece of paper, sand will not get attracted to the magnet. So the material that stick to the magnet are called magnetic material, while those that do not stick to the magnet are called non-magnetic material. Magnetic material किसको बोलते हैं हम? The material that gets stick to the magnet उनको हम बोलते हैं magnetic material, और जो stick नहीं होंगे उनको हम बोलते हैं non-magnetic material. The metal iron, cobalt, nickel are the magnetic material. So, in the past, there is a legend about the discovery of magnet. It is said that the shepherd named Magnetes lived in Greece. Okay, so Magnetes was a scientist who used to live in Greece. He found this phenomenon of magnetism. Once, while sheep were grazing, he was a shepherd and he sat down on a big sock. But what surprise he got when he tried to get up, his staff and his shoes were stuck to the rock. Okay, सो उसके जो शूज थे वो रॉक को स्टिक हो गए एंड ही हैड टू यूज अ ग्रेट फोर्स टू पुल हिमसेल्फ अवे फ्रॉम द रॉक. तो उस रॉक से वो डिटैच होने के लिए he required a lot of force. उसे बहुत ज्यादा फोर्स लगानी पड़ी just to pull himself away from the rock. He realized that what had happened was because of the iron ferrule on his staff and the iron nails in his shoes. So simply the iron nails were present in the shoes, okay, and however other rocks did not stick to his shoes or staff. Okay, later he showed that rock to everybody. He showed that rock to everybody and he told that this rock has a effect of magnetite. So that effect was named as a magnetite after his name Magnesium, the shepherd. And magnetite is a natural magnet. It's a natural magnet which attract the iron. It is also possible that name magnet came from Magnesia, the part of Greece where the magnets were discovered. So Magnesia is a part of Greece where the magnet was discovered. That's why the name magnet was given. So we have to find out this. How was mariner's compass used? It used the magnetic effect, but it was known quite long ago to the people in China and Europe that a piece of magnet hung freely always settled to the north and south direction. तो अगर आप magnet का piece freely hung करते हो तो at that time it comes in the direction of north and south. Okay, and this rocks then came to be used to finding the direction while traveling through the unknown region. So ये जो थी this concept was used to find out the direction while traveling. So that is why they were also called as a idol stones, leading stone, which will show the direction that if you keep this magnetite, मतलब ये जो rock है, if you keep it hung freely, it comes in the north and south direction. इसलिए उनको direction find out करने के लिए रखा गया and that was also named as leading stones or idol stone. This led to this invention of the mariner's compass. Magnet can have a variety of shape depending upon their use. So magnets have a variety of shapes. उनकी uses पे depend करता है. Today, magnets are used in many machines and gadgets or devices, and they are all man-made magnets. Okay, आज हम बहुत सारे machines में magnet use करते हैं. They are all man-made. Find out where the magnets shown in the picture below are used to find out how is mariner compass used. Okay, आप ये पता लगा सकते हो कि how the mariner's compass is used. Generally, bar magnet, disc magnet, horseshoe magnet, ring shaped magnet, cylindrical magnets are also small button magnets are the different shape of magnet. तो magnet के बहुत सारे shape रहते हैं. Bar magnet, it looks like a bar. Disc magnet, it is round in shape. Horseshoe magnet, it is like a horseshoe. And ring shape, so it is like a it will be in the form of ring. Cylindrical, it will be form of the cylinder. So these are the various types of magnets that you can see. These are the various shapes of the magnet. तो आप यहाँ पे देख सकते हो horseshoe magnet, bar magnet, ring shape magnet, cylindrical magnet. Okay, so these are the various types of shapes of magnet and these are the man-made magnets. Now, let's talk about the magnetism. When a magnet attracts an object, that object is displaced due to the magnetic force. तो जब भी magnet किसी भी object को attract करता है, मान लो this is an iron object, it will displace due to the magnetic force. तो ये magnet उसके ऊपर magnetic force लगाता है and like see in places like factories, ports, gadget depots, large objects are shifted from a place to place. तो बड़े बड़े फैक्ट्रीज में अगर आयन का, कोबाल्ट का, निकल के कोई ऑब्जेक्ट्स है that can be moved from one place to another because of the magnetism, because this magnet do attract the objects such made up of nickel, iron that can be shifted from one place to another. So that's for this purpose crane with a magnet are used वर्क इज डन बाय अ मैग्नेटिक फोर्स, एंड जब भी ये मैग्नेट उनके ऊपर फोर्स लगाता है तो मैग्नेटिक फोर्स इज अप्लाइड एंड वर्क इज डन by the magnet on the object, and we can use this, okay, in the form of energy, okay, and you can move the object. What are the characteristics of magnet? अगर हम मैग्नेटिज्म के मैग्नेट्स के characteristics consider करें, determine the direction in the class or the laboratory, tie a thread to the center of a bar magnet and hang it freely. तो बार मैग्नेट को सेंटर पे थ्रेड डालना है एंड यू हैव टू हैंग इट फ्री. नोट द डायरेक्शन इन विच द मैग्नेट सेटल्स एंड टर्न इट अराउंड अगेन. लेट इट सेटल एंड नोट द डायरेक्शन. डू दिस मेनी टाइम्स. व्हाट डू यू ऑब्जर्व? तो इसको फ्रीली रखना है, ओके, एंड फिर उसके बाद में क्या करना है, उसका डायरेक्शन चेंज करके फिर से उसे सेटल करना है. तो द मैग्नेट ऑलवेज सेटल्स इन द नॉर्थ एंड साउथ डायरेक्शन. आप उसका कोई भी डायरेक्शन चेंज कर लो बट इट विल ऑलवेज सेटल इन द नॉर्थ एंड साउथ डायरेक्शन. This is the property of magnet. This is the characteristics of magnet, that a magnet always settle in the north-south direction. Now, the end of magnet that points out to the north is called north pole. जो नॉर्थ को पॉइंट आउट करेगा उसको हम बोलेंगे नॉर्थ पोल. जो साउथ को पॉइंट आउट करेगा उसको हम बोलेंगे साउथ पोल. सो मैग्नेट has two pole. One is a north pole, another is a south pole. North pole is denoted by N, south pole is denoted by S. And the place some iron fillings around this, okay, around the sheet of paper and pass the bar magnet. Okay, then pick up the bar magnet by holding it to a center. What we see to which part the magnet do most ion filling. तो ये जो नॉर्थ एंड साउथ पोल है उस पोल पे ज्यादा पार्टिकल्स अट्रैक्ट होते हैं एज कंपेयर टू द सेंटर, बिकॉज द मैग्नेटिक फोर्स इज कॉन्सेंट्रेटेड एट टू एंड्स ऑफ द पोल ऑफ द मैग्नेट. तो जो वो मैग्नेटिक स्ट्रेंथ रहती है, मैग्नेटिक फोर्स रहती है, दैट इज ऑलवेज एट कॉन्सेंट्रेटेड एट टू एंड्स ऑफ द पोल्स. See, take a bar magnet that can be cut with the scissor or knife. Take an iron filling or a sheet of paper. Place the magnet on it. Most of the iron fillings will be seen to stick to its pole. Now, cut the magnet into two pieces as shown in the figure. तो हमें क्या करना है? We have to go on cutting the magnet into two pieces. Although if you cut the magnet into two pieces, what would happen? The magnet still will attract the pieces of iron at the two poles. That means we can say, आप अगर उसको कट भी करते हो तो उसका नॉर्थ एंड साउथ पोल फिर से आएगा. इसको कट करोगे तो नॉर्थ एंड साउथ पोल फिर से आएगा. That means if a magnet is divided into two parts, two independent magnets are formed. It means that two poles of a magnet cannot be separated. अगर आप उसको कट भी करते हो तो each and every part of the magnet will have its north and south pole. So two poles cannot be separated. ये north and south poles को आप separate नहीं कर सकते. This is the property of a magnet. Now, fix a powerful bar magnet to a stand as shown in the figure. Fix an iron bar at a short distance below the magnet. Take an iron filling near the iron bar. ओके, हमें पावरफुल बार मैग्नेट को स्टैंड पे फिक्स करना है, आयरन बार at short distance, and take a iron filling. What do you see? After some time, take a magnet away. What happens? Iron fillings stick to the iron bar when the magnet is near to it and fall off as soon as the magnet is taken away. मतलब मैग्नेट है, मैं उस मैग्नेट को मैं अटैच करती हूँ आयरन बार, because the iron bar will get attracted by a magnet. तो क्या होता है? Simply ये जो magnet है that is coming in contact with the iron bar will acquire the magnetism. वो भी magnetic property acquire करेगा. It will acquire magnetism. and अगर इसके पास अगर आप दूसरा कोई भी iron का particle लाओगे, it will get attracted. Okay, why it will get attracted? Because iron bar has a मैग्नेटिज्म. लेकिन एज सुन एज यू रिमूव दिस आयरन बार, अगर आप इस आयरन बार को रिमूव करते हो तो ऑब्जेक्ट भी वो attract नहीं होगा, it will lose its magnetism. So it's simply a magnetic material acquires magnetism when placed near the magnet. तो जो भी magnetic material है, if it is come in contact with the magnetism in place near the magnet, it will acquire the magnetic property, and this magnification is called induced magnetism. उसको हम बोलते हैं induced magnetism, जिसमें magnetic properties induce होती है. Now यहाँ पे देखो, fix a bar magnet to a stand as shown in the figure. Let it become steady. Take another bar magnet near the hanging bar. Observe what happens. Do the same again and again, exchanging the ends of the magnet. What do you see? Okay. There is a repulsion between the like pole. मतलब अगर ये बार मैग्नेट है, इसका ये नॉर्थ है, इसका ये साउथ है. सेकेंड मैग्नेट मैंने पास में लाया साउथ एंड नॉर्थ पोल. तो ये जो साउथ साउथ है वो रिपेल करेंगे. They will exert a opposite force. They won't get attract. They will repel with each other. अगर मैं नॉर्थ पोल और दूसरे मैग्नेट का भी नॉर्थ पोल लाती हूँ तो भी ये रिपेल करेंगे. They won't come together. Okay, there will be also a repulsion. There will be a repulsion. But if I'm taking north pole of one magnet and taking south pole of another magnet, so there will be attraction. वहाँ क्या होता है? There is attraction. So it's simply the repulsion. If we talk about the magnetic property, there is a repulsion like poles of the magnet, while there is a attraction between the opposite pole. So like pole मतलब south south will repel each other, and north south will attract each other. Opposite pole attract each other, like pole repel each other. This is a simple concept. Now take a needle or a nail, place it steady on table. Keep on rubbing a magnet over it from one end to another. Do this 7 to 8 times. Now take a few pins near that needle, nail what is seen. In this way, magnetic objects acquire magnetism. Magnetism of this kind is temporary and it lasts for a short while. Okay, now हमें क्या करना है? आपको एक needle nail लेनी है. We have to keep that near a table. Okay, place it on steady table. Keep on rubbing a magnet. Okay, जब तक आप उस पे magnet rub कर रहे हो तब तक उसमें magnetism effect रहेगा. Okay, as soon as you remove the magnetic material, there won't be a magnetism. मतलब इसमें जो magnetism property है वो ज्यादा देर तक नहीं रहेगी. That will be the temporary magnetic effect. उसको हम बोलते हैं temporary magnetic effect. Now let's do a little fun. We'll make a electromagnet. तो electromagnet क्या है? हमें एक iron nail लेनी है. See in this picture it has given. अभी इस iron nail को, okay, iron nail of 10 centimeter length, we have to take 1 meter long insulated copper wire, and उस copper wire को हमें इस nail पे wound करना है, and we have to attach this connection to the battery. So as soon as you apply this end to the battery, there will be a flow of current. Okay, तो जब भी यहाँ पे flow of current होगा, automatically ये iron nail जो है, this will start attracting the another small pins. ऐसा क्यों होता है? Because whenever the electric current is passed through the coil, this coil is attached with this iron nail. This iron nail will acquire magnetism because the current flowing through the conductor will produce magnetism, and that magnetism get induced in a iron nail, and इसको हम बोलते हैं electromagnet. This concept is known as the electromagnet. We are making a magnet using electricity, because when you pass the electricity through this, there will be a generation of magnetism, and this magnetism will be induced in the iron nail. Now, during the above activity, we saw that the pins stick to the nail. Now stop the electric current and see. अगर आप electric current stop करते हो तो obviously there won't be a attraction with the nail. क्यों होता है? Because magnetism is produced in the nail due to electric current. इलेक्ट्रिक करंट की वजह से उस नेल में मैग्नेटिज्म प्रोड्यूस होता है, and when it is put off, the magnetism vanishes. Such magnet is called electromagnet. Okay. तो जब भी आप करंट फ्लो करोगे वहां पे मैग्नेटिज्म फॉर्म होगा, and that phenomenon is known as a electromagnetism, and उस मैग्नेट को हम बोलते हैं इलेक्ट्रोमैग्नेट. This magnetism is temporary and the electromagnetism is used in many places in our daily to day life. Daily to day life में हम इसका यूज बहुत सारी जगह पे करते हैं. Now, for example, it is used in the instrument such as doorbell. Doorbell में हम use करते हैं. Okay. On the other hand, the magnet fixed to a pin holder of the door of a cupboard as a permanent magnet. Permanent magnets are made up of from mixture of nickel, cobalt and iron. इनका मिक्सचर करके हम परमानेंट मैग्नेट बना सकते हैं. We are inducing the magnetic effects in them, and the material alnico is a mixture of aluminium, nickel and cobalt. Okay, so this is in this way the material is made. Now, in the past, the British scientist Michael Faraday developed the technique of producing electricity with the help of magnet. अभी मैग्नेट में जो मैग्नेटिज्म है वो तो नेचुरल है. जब भी आप करंट फ्लो करते हो किसी भी कॉइल में तो उस वहां पे भी मैग्नेटिज्म जनरेट होता है. लेकिन फैराडे ने क्या किया, यूजिंग अ मैग्नेट ही सिंपली जनरेटेड इलेक्ट्रिसिटी. सो द मैग्नेटिज्म टेक्निक वाज यूज्ड बाय द फैराडे फॉर प्रोड्यूसिंग इलेक्ट्रिसिटी. And Faraday was born in a poor family. As a young boy, he had to work with a bookseller. There, he had read many books and developed an interest in science. Later, he went on to the research to the Royal Institution, London. It is due to the Faraday's research that today we can use electricity, electromagnetism in innumerable instruments in our day-to-day life. तो Faraday ने मैग्नेट यूज करके उसने इलेक्ट्रिसिटी जनरेट की. हमें ये तो पता है कि इलेक्ट्रिसिटी जब जनरेट होती है तब मैग्नेटिज्म इफेक्ट ऑटोमेटिकली आ जाता है, लेकिन यूजिंग अ मैग्नेट ही ट्राइड टू जनरेट द इलेक्ट्रिसिटी, एंड दिस एप्लीकेशंस करंटली हैज यूज्ड इन मेनी इंस्ट्रूमेंट्स. Now, the properties of electromagnetism and repulsion between the magnet is used in a maglev train. तो ये जो प्रॉपर्टी है, द प्रॉपर्टी ऑफ इलेक्ट्रोमैग्नेटिज्म एंड रिपल्शन between the magnets are used in the Magellan train, and due to this repulsion between the train and the rail of the force of friction does not come into the play and train slides over the rail with the great speed. तो यहाँ पे क्या कॉन्सेप्ट है, मतलब ये जो रिपल्शन का फिनोमिनॉन है दैट हैज बीन यूज्ड इन द रेल ट्रेन, जहाँ पे रिपल्शन होता है between the two magnets, and due to that there is no friction, the force of friction does not come into play and the train slides over the rails with a great speed से वो slide कर सकती है, and the magnet fixed on the two sides of the train help to move forward. तो यहाँ पे भी मैग्नेट रहता है एंड इवन द रेल इज मेड अप ऑफ मैग्नेट, लेकिन यहाँ पे अपोजिट like poles रहते हैं, so there is a repulsion, there won't be a friction and the trains can easily travel a high speed. Now, there's a strip of a magnet material in ATM card, credit card, where necessary information about the user is stored. Okay, so यहाँ पे ATM card इसमें एक strip रहती है and it has a very important information, and the magnetic material are also used to store data in the hard disk of computer, audio, video tape. तो मैग्नेटिक मटेरियल यूज किए जाते हैं यहाँ पे जहाँ पे हमें डेटा स्टोर करना पड़ता है. Now, how is magnetism is destroyed? Magnetism gets destroyed when a magnet is heated, thrown, knock about the broken spaces. Okay, अगर हम उसको हीट करते हैं तो मैग्नेट की प्रॉपर्टी लूज हो जाएगी, नॉक करते हैं या फिर if get broken into pieces, the property of the magnet will be lost. Therefore, it is important to store the magnet carefully. इसलिए उसको अच्छे से रखना है, उसे हीट नहीं करना, उसे हैमर भी नहीं करना, उसे पार्टिकल तो we cannot throw that magnet anywhere. Okay, and magnet needs to be stored properly. The bar magnet A bar of soft or pure iron protects the magnet. Therefore, such magnets are called magnet keeper. तो यहाँ पे आप देख सकते हो, this is the magnet keeper. यहाँ पे iron bar of pure iron is used and it will protect the magnet. Always remember, various scientific discoveries, the knowledge we gain through them. The various instruments or gadgets we develop with the help of all useful by the progress of the man. They must be used for the good of mankind. So we have to take precautions while working with electricity. तो electricity जब हम use करते हैं, we have to take a lot of precautions. Okay, so what we have learned, we know iron, nickel, cobalt are magnetic metal. Magnets settle along the north and south pole. Magnetism is concentrated near the pole. The pole of magnet cannot be separated, and the electromagnetic energy is used in our daily to day life. So iron, nickel, cobalt, these are magnetic material which get attracted with the magnet. Okay, हमेशा magnet north and south pole में settle होता है. उनकी जो magnetic strength है, it is always at the poles. They cannot be separated, and the electromagnetic energy is used in our day to day life. So this is about the complete chapter. We have seen the characteristics of magnet and we have seen the electromagnetic phenomenon. So here we have successfully completed this chapter. Thank you.